All right, hello chemistry class. In today's video, what we're going to do is we're going to look at double replacement reactions. So you should have your notebook out. You should be turned to page 9 and 10 in your composition notebook, and you should get the solubility table out that I gave you in class. And this is going to be very helpful, and you need to have this solubility table out in order to look up the solubilities. Now, first of all, let's review a little bit about what a double replacement reaction looks like. Remember, we talked about this in a couple of videos ago. A double replacement reaction would have the general format of AB, compound AB plus compound CD, and they produce compound AD plus CD. So you start with two compounds and you form two compounds. And simply what happens is the cations switch places. So A switches places and bonds with D, and C switches places and bonds with B. Now, a double replacement reaction will only occur if, number one, both reactants are aqueous. So they must be aqueous. How are you going to know? Is you're going to look them up on the solubility table and determine whether they are soluble, which means they would be aqueous, or insoluble, which would mean they would be a solid. At least one of the product has to be a solid, or it could be a liquid, or it could be a gas. So both reactants have to be aqueous, and then one product is usually going to be aqueous and the other one is usually going to be a solid, or it could be a liquid or gas. If neither one of these conditions exist, then we would say no reaction. So both these conditions have to exist in order for it to be a double replacement reaction. Now, the key in doing double replacement reactions and predicting the products is to correctly write the formulas. We need to make sure that we look at the charges and that our charges are written correctly, that our subscripts are written correctly, so that the charges cancel out and the charge equals up to zero. So your positives and your negatives equals out to zero. Now, I picked up this from some other chemistry teachers, and it works really well, and students really catch this. The way you do this is use what we call a little scratch pad, which is basically just a little small box that you're going to draw on your paper as you do these examples. I'll show you exactly what I mean coming up next. So let's take a look at a few examples of these. In your notebook, you'll want to copy these down as well. So the first one is sodium chloride. So example number 1, NaCl. All right, this has to be an aqueous solution, and sodium chloride is aqueous, plus silver nitrate. All right, now silver nitrate is also an aqueous solution. Now, then you got to say, well, what do these compounds form? So here's what you're going to do is over here on your paper, down here below or something like that, just draw you a little box like so, okay? And that's what I'm talking about. I'll call that a little scratch pad. And then what you're going to do is you're going to write your positive ions across the top. So you're going to have sodium, Na, and that's always going to be a +1 charge. You're going to have your silvers, your other cation, so it's going to be written there. And then you're going to write the negative ions right underneath it. So you're going to have chloride, 1 negative, and nitrate, NO3, 1 negative. And then what happens is these crisscross, they trade places. So sodium is going to trade places and bond with nitrate, and silver is going to trade places and bond with chloride. And so sodium, nitrate bonds together. So we're going to have a +1 and -1. And so that's going to be a 1-to-1. So that's just going to be NaNO3. And leave you a little room here. We're going to go back and check solubilities here in just a few minutes. Plus silver is going to bond with chloride, and it's a +1 and -1. So that's going to be AgCl on that one. All right. So now we need to get our solubility table. And you have some solubility rules, some general solubility rules. So if you'll memorize these rules, it'll help you do these things quicker. Or you can look them up on your solubility table. So the first one we have is sodium nitrate. So we look down here and we find our sodium right here, and then we go across to the column where we see nitrate. Nitrate's right here. The thing is nitrates are all soluble. So we have an S here. Now, S does not mean soluble in this table. It does not mean solid. It means soluble, okay? And so if it says an S, then we write AQ in our equation. I know that can be a little bit confusing, but remember the table, S stands for soluble. All right, and then we check out silver, okay? So we go to our solubility table and we find silver, and we go over and we find chloride, and we see an I here. That's not a 1, that's an I. I stands for insoluble. So if it's insoluble, all right, we write a S for solid here, okay? All right. In fact, at the bottom of the solubility table that I gave you in class, I sort of helped you out. And so S on the table means it's aqueous. P means it's partially soluble. So that means we're going to count it as a solid because it will produce a precipitate. I is insoluble, so we'll count it as a solid. And if it says a D, that means it decomposes, and we're just going to count those as aqueous. So these will be the symbols that you're going to use for each one of those. All right, now we need to make sure this is balanced, and this one is already balanced. And so since one of the products is a solid, then we know that this reaction will occur. And those would be the two products that would be formed. All right, let's try another one here. Let's do K2SO4, all right, plus CaNO3, 2. All right, now this time we have to look up our solubilities, all right? And we look them up on our table and we see potassium sulfate. So again, we just get our table and we find our potassium right here. All right, then we go across until we find the sulfate. It's all the way out here. Potassium sulfate is all the way out here. And so we'll call that potassium sulfate. It's an S. I was looking at the wrong column there. Almost confused me there for a second. And so that one's soluble. Okay, so we're going to put AQ right here as well. All right, then we have calcium nitrate. All nitrates are always soluble, all right? So if you can remember that rule, all right, then you can just put aqueous for that one. And then we need to draw a little scratch pad down here, okay? It only takes a few seconds to do this, and it will help you out tremendously if you'll just take this extra little time to do this. All right, so we're going to have potassium. It's a +1 charge. We're going to put sulfate underneath it. It's a 2 negative charge. We'll have calcium is a 2+ charge. We just get that from your periodic table like we've done in the past. And then we'll have nitrate, which is a 1 negative charge. All right, so the potassium is going to switch places and go with the nitrate. The calcium is going to switch places and go with the sulfate. So potassium nitrate is KNO3 plus calcium sulfate is going to be CaSO4. Since calcium is a 2+ and sulfate's a 2 negative, those will balance out. And so it really doesn't matter. I could have put calcium sulfate here and then potassium nitrate. It doesn't matter what order the compounds are, but remember potassium has to go with the nitrate and calcium has to go with the sulfate. We always write your positives first, your cations first, okay? So then we need to look it up. Nitrates are always soluble, okay? So we have AQ for the nitrates right there. And then we have calcium sulfate. So we find calcium on our solubility table. We look over and sulfate, and here's calcium, and here is sulfate right over here, and so we get an I. All right, so that means it's insoluble. So that means it is a solid. So we use S for a solid. Now we need to make sure this thing is balanced. All right, if it's not balanced, we need to balance it. All right, so we have 2 potassiums on the left. We only have 1 here, so we need to place a 2 in front of that. We have 1 sulfate and 1 sulfate. We have 1 calcium and 1 calcium. We have 2 nitrates, and now we have 2 nitrates because we placed the coefficient of a 2 in front of that one. So we're good on that one. All right, let's try another one. Let's try NH4, okay, 2, CrO4, so ammonium chromate, okay, plus iron 3 nitrate. Okay. And we're going to see what this one forms here. All right. Now we need to look up our solubilities, and we do that in ammonium chromate. When we look it up, we see that it is soluble, so we put AQ for that one. We have iron nitrate. Again, all nitrates are soluble, so we're going to put an AQ for that one. Need to squeeze that in a little bit. We're going to draw our little scratch pad down here to put our ions on. We're going to put our positives on top, NH4 plus, and we're going to have Fe 3+. You say, well, how do I know it's 3+? Well, because there were 3 nitrates, and each nitrate's a -1, so that means iron had to be a 3+. All right. And then we're going to have chromate down here at the bottom. Okay, make sure it's underneath the one that it originally went with. All right. And chromate is going to be a 2 negative. And then we have nitrate, NO3, 1 negative. So the ammonium is going to bond with the nitrate. The iron is going to bond with the chromate. All right. So we're going to have +1 and -1. So that's going to be NH4, NO3, and nitrates are aqueous. We can go ahead and put the aqueous symbol right there. Okay. Plus iron's going to bond with the chromate. Now there are 3 plus and a 2 negative. So what that means is we're going to need 2 irons and we're going to need 3 chromates for our charges to cancel out. All right. So if you need to work that out, you can work that out just like we've done in class and everything. Hopefully you're getting better at doing that a little bit quicker. So now we need to check our solubilities, and we check and we see iron chromate, and we find it, and we see iron right here, and then we have chromate. All right. And so iron chromate gives us this little line right there. So I told you with iron 3, I was on the wrong line here. It gives us an I, so that one's insoluble as well. So we're going to put an S beside that one. Now we need to balance this. And for our iron, we have 1 iron here. We have 2 over there, so place a 2 in front of that. And then our nitrates, 2 times 3 is 6 nitrates. So therefore, we need a 6 in front of this one. That will give us 6 nitrates. That will also give us 6 ammonium, 6 NH4s. So we need to come back over here and put a 3, because 3 times 2 is 6. And then for our chromates, well, we've got 3 chromates here. 3 times 1 is 3 chromates there. So now it is okay. It's balanced out just fine. All right. Let's do another one. Let's do NaCl plus KNO3. Okay, KNO3. So we do this one, and sodium chloride is aqueous. All right, potassium nitrate is also aqueous. So that meets the first condition. Now we do our little scratch pad. Okay, move this up so you can see it better. And we're going to have Na 1 plus, Cl 1 negative. We're going to have K 1 plus, and then nitrate NO3 1 negative. All right, so these will switch places, and sodium nitrate plus potassium chloride. Now, nitrates are always aqueous, and potassium chloride, if you look it up, it's also aqueous. So we got an issue here. Remember what we said? Look back in your notes. Both your reactants must be aqueous, and one of your products must be either a solid, a liquid, or a gas. So since we don't have a solid, liquid, or gas, okay, this is not solid or liquid or a gas, then what do we say? No reaction, okay? Or we could just put NR for no reaction. And that's what we'd write down, and we wouldn't want to move any farther than that, and we would just want to simply put down no reaction for that. All right, so let's take a look at some of these, some equations with words, all right? You need to be able to do these as well. So equations with words. All right. And we're going to go from the words, and we're going to make them formulas. So let's say we have a sodium iodide solution. So copy this down in your notebook. Sodium iodide is added to a solution of lead 2 nitrate. All right. So now we have it in words, and we're going to convert this over to a formula. So it's still a good idea to go back and underline all your chemical compound names. So we have sodium iodide and lead 2 nitrate. Now we want to make sure that we write the correct formulas for these. So we have sodium is Na, check your charge is +1, iodide is -1, and so the formula is NaI. And then it says it's added to, so we're going to say plus. Oh, basically it says it's a solution, so we automatically know it's aqueous. We could look it up, but it tells us in the word equation that it is a solution. And then it's added to a solution of lead 2 nitrate. So lead is Pb 2 plus, nitrate is NO3 1 negative, and so we're going to need to have Pb NO3 2, and this is aqueous as well because it's in solution. All right, so now we've got it into a formula equation. So now we just do our little scratch pad, just like we've done in the previous examples, and we're going to break them up. So we're going to have sodium +1, iodine 1 negative. We're going to have lead 2, so that's a 2 plus, and we're going to have nitrate 1 negative. So the sodium switches places and goes to the nitrate, and the lead 2 goes with the iodine. So we're going to rewrite them. NaNO3, and that's aqueous because it's a nitrate, okay, plus PbI2. And so we look up the solubility of lead iodide, and we find out that it is, in fact, a solid. So we put an S right there. So that meets our conditions. All right. Now we need to make sure we balance this, and we need to put a 2 right here. We need to put a 2 right there. And so now it's okay. Now it's taken care of, and everything is balanced on that one. All right, let's do one more. Okay, one more with words. Let's say a solution of potassium hydroxide. Okay, is added to a solution of tin-2 chloride. Okay, solution of potassium hydroxide, so we have that, is added to a solution of tin-2 chloride. So potassium is K with plus charge, hydroxide is OH with a 1 negative charge, so that's going to be KOH plus, all right, tin-2, so that's SN2 plus, Cl 1 negative, so we're going to have SnCl2, and that's a solution, so that's aqueous. That's a solution, so that's aqueous. So our first condition is met. We're going to make our little scratch pad just like we've done in the past. All right, we're going to put positive potassium with a positive 1, OH 1 negative. We're going to have tin with a 2 plus because it's tin-2, and chlorine with a 1 negative. So tin is going to go with the hydroxide, potassium is going to go with the chloride. So we're going to write SnOH2. Okay, we make sure the 2 is on the outside of the parentheses, plus KCl. All right, so we check our solubilities here, and we find that tin-2 hydroxide is insoluble. So we put an S right beside that one, and we find that potassium chloride is soluble, so this reaction will occur. Then we need to make sure that it is balanced, and we look at that, and we need to put a 2 in front of the K, so we can get 2 OHs, and we need to put a 2 in front of that one so that we get 2 potassiums and 2 chlorines, and we have 1 tin, so it is all balanced. Okay, so we're going to do plenty of examples of this in class and give you a chance to do some worksheets on this, and if you have any questions, make sure you bring them to class. I look forward to learning some chemistry and having a lot more fun.